So welcome guys, welcome to my channel. Today in this lecture I will discuss a problem from GATE 2018, and this problem is of conductance. Okay, so the problem is here. It came with 2 marks, right? So the problem is the molar conductivity of a 0.01 molar weak acid at 298 K measured in a conductivity cell with cell constant of 0.4 centimeter inverse is this one. The limiting molar conductivities at infinite dilution of this one and this one at 298 K are this one and this one respectively. So ignoring activity coefficients, the pKa of this acid at 298 K is this one. Okay, so they asked about the pK, so up to 2 decimal, right? And with 2 marks. So the main thing is that they told that we have to ignore the activity coefficient. So as we know that activity equals to concentration, okay, into activity coefficient. So for real system or real molecules which we are deal in lab or laboratory or experiment, actually we have to calculate the activity of those molecules. Although we calculate the concentration in numericals in physical chemistry problem, but this is not the correct thing, right? Because because there is also a term that is activity coefficient. This relation holds. So here they told that this is ignored, means this is taken as 1, right? So that's why activity equals to concentration. In one way we can say that we are just calculating the activity because this is 1. So that's why we are in one way we are calculating activity, means concentration means activity when this is 1. So the main thing is that they asked about the pK. So as we know that pK is what, minus log of K, equilibrium constant. So first the basic things is that to solve this problem they asked about, we have to go back side, right? So they asked about the pK, so we have to take the negative log of K. Now the K will come from where? K will come from that dissociation. So the dissociation of the Hx is equals to what? H plus X minus. So Ka. So again we have to go back that chemical equilibrium problem. So in that case dissociation, we know that at T equals to 0 it is concentration at initially, or means time when the reaction initiates, that time the concentration of this one C, and this is 0 0, and after time T, okay, this will be what, C into 1 minus alpha, and this is C alpha. So Ka equals to what? C alpha into C alpha by C into 1 minus alpha. So this will be, right, C cancels, means C base square by 1 minus alpha. Okay, so this is according to the Oswald dilution law. So we can give this relation. Now C is given, so K, for K C is given. Now the question is alpha. From where we can get the alpha? So for conductance we know that alpha is given as the ratio of the molar conductivity to that of the molar conductivity at infinite dilution. So molar conductivity again it is given. So the given data I am writing here, given data as molar conductivity is given, and the conductivity cell constant is also given, and the limiting molar conductivity is also given. So I am writing the given data. So the given data, so up to we are here, and so alpha, okay, so here the given data are cell constant equals to what? L by A. Cell constant equals to what? 0.4 centimeter inverse. Molar conductivity, I am writing direct the equation. Molar conductivity equals to what? Molar conductivity is 64.4 Siemens centimeter inverse mole inverse. Okay, and limiting molar conductivity at infinite dilution, so lambda H plus equals to what? 350 S centimeter square mole inverse, and lambda X minus equals to 410 S centimeter square mole inverse. So from here, so according to this one, so this is at infinite dilution. So according to Cole-Lash law, what we can write that lambda m infinite equals to what? Lambda H plus lambda X minus. So this is this will be 2 summation, so 350 plus 410, okay, centimeters square mole inverse. So this will be 760 centimeter inverse mole inverse, okay. So now from here again going back, so here it is, they want that C, this one, so C is given, this is actually in terms of molarity the concentration, this one molarity in terms of molarity, the molarity is this one, this is the concentration, right? So in terms of molarity or normality, either here it is that molarity, this is also the normality, okay, because this is the mono one proton is there, right? So in this case alpha equals to what? Again we know that alpha equals to lambda m by lambda m infinite. So by dividing these two we can get the what? Alpha. So we will go to the next step, okay. So here alpha equals to lambda m by lambda m infinite. So lambda m is given is what? Lambda m equals to 64.4 by 760. So this will be 0.084, right? And this dissociation again, we got that Ka equals to C alpha square by 1 minus alpha. So this is according to the what? Oswald dilution law. So we are not ignoring this one here, okay. We can ignore also because this is very much less than 1. It is very much less than 1, then we can ignore. But here as the data values are given, so we are not ignoring this one. So we will put the value and C equals to 0.01 molar. This is the molarity. So 0.01 into 0.084 square 1 minus 0.084. Okay, so by calculating this one we will get what? You just calculate 0.01 into 0.084. now the work will do, will do the work 0.916. so from here we will get Ka equals to 7.7 into 10 to the, I have already done this problem, okay, and I have the data, that's why I'm writing, okay. So this is the Ka, and now pK, right? So pKa equals to minus log of Ka, and that of minus log 7.7 10 to the power minus. We just put the value and we'll get the data, we'll get the answer. So that will be what? 4.11. So the pKa equals to 4.11, okay. So again we know that pK, so higher the pK, lower the acidity. One statement regarding that information, so higher the pK, okay, lower the acidity. So for the acids this will be very less, like 2 3, again it is the minus also, and for base it will be the value will be higher. So we can write that pK inversely proportional to acidity, right? This equation. So this will be helpful for you on 2 marks in organic chemistry, right? That GOC in 2 marks in your CSIR exam usually come this with, so they will give you the pK data and they will ask the basicity or acidity in this way. So this problem is actually, this is a good problem and this is a beautiful problem, right? So this actually relates a lots of relation. So one is that conductance, another is that chemical dissociation, right? Oswald law, those things. And again there is also the concept of activity and concentration, so all the things. And again that is the pK. So if they can give also the two right, like 2 acids and give with like calculating the pK, which is the strong acid, that's for organic chemistry. So a number of equations, number of concepts in this are there in this equation. And one thing is that there is also given the cell constant, but cell constant is of no work here. This is just given, they give, so just this is given for just confusing you, right? So this is the way, so in this way we can solve this problem, okay. So thanks for watching this video. So like, share and subscribe our channel.